This is Dr. D. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering. Today we will discuss the domain specifics IoTs under the course Principles of IoT. The slides are prepared by referring the textbook Internet of Things, a hands-on approach by Arshdeep Baga and Vijay Madhisetti, publication Universities Press. In this session, we will discuss the domain-specific IoTs. The various domain-specific IoTs we are having are home automation, cities, environment, energy, retail, logistics, agriculture, industry. Last one is health and lives. The Internet of Things application span a wide range of domains, including homes, cities, environment, energies, systems, retail, logistics, industry, agriculture, and health. So this chapter mainly gives the overview of various types of IoT applications. So under home, we are going to have a smart lighting, smart applications, installation detection, smoke gas sensor. Under cities, we have a few applications like smart parking, smart roads, structural health monitoring, emergency response, and surveillance. Under environment, we can have the applications for weather monitoring, air pollution monitoring, noise pollution monitoring, forest fire detection. Under energy, we have few applications: smart grid, renewable energy systems, and prognostics. Under retail, we have a few applications like inventory management, smart payments, smart vending machines. Under logistic, we have applications like route scheduling, fleet tracking, shipment monitoring, remove vehicle diagnostics. Under agriculture, we have few applications like smart irrigation, greenhouse control. Under industrial applications, we have applications for mission diagnostics, indoor air quality monitoring. Under health and life science lifestyle, we have applications for healthcare and wearable electronics. Now we will see the first applications which is related to home automation. So this is a figure shows a typical home where we can see a few applications we can have, where we can have the smoke and fire sensors for detection of the smoke and fire. Smart appliances we can have. Smart lighting systems we can have. Smart thermostats we can have. And here detection of the installation. Now we will see what is a smart lighting. Smart lighting for homes helps in saving energy by adapting the lighting to the ambient condition and switching on or off or dimming the lights when it is needed. The key enabled technologies for smart lighting includes solid state lighting such as LED lights and IP enabled lights. For solid state lighting solutions, both spectral and temporal characteristics can be configured to adapt the illuminations to various needs. Smart lighting solution for home achieve energy saving by sensing the human movements and their environments and controlling the lights accordingly. The wireless enabled and internet connected lights can be controlled remotely from IoT applications such as a mobile or web application. Smart lights with sensor for occupancy, temperature, etc. can be configured to adopt the lighting by changing the light intensity or color of the smart lights, etc. based on the ambient conditions sensed in order to provide a good ambience. In controllable LED lighting system is presented that is embedded with ambient intelligence gathered from a distributed smart wireless sensor network to optimize and control the lighting system to be more efficient and user oriented. These are the few cases which we are going to be over. So, a solid state lightning model implementing on a wireless sensor network that provides services for sensing illumination changes and dynamically adjusting the luminary brightness according to the user preferences. Under home automation, the next one is we have smart appliances. In modern homes, have a number of appliances such as TV, refrigerator, music systems, washers, dryers, etc. Managing and controlling these appliances can be cumbersome with each appliances having its own controls or remote controls. Smart appliances make the management easier and also provide status information to the users remotely. For example, a smart washer or a smart dryer that can be controlled remotely and notify whenever the given activity like washing or drying cycle is completed. So the smart thermostats allows the controlling the temperature remotely and can learn the user preferences. Smart refrigerator can keep track the item stores. Maybe that items may be containing the RFID tags for identifying the elements or the goods which are stored and send the updates to the user whenever an item is low on stock. Smart TVs allows user to search and stream videos and movies from the internet on a local storage drive, search TV channel schedules and fetch news, weather updates and other context from the internet. Open Remote is an open source automation platform for homes and buildings. So this Open Remote is a platform agnostic and works with standard hardware which we can use for home automation applications. With Open Remote, the user can control the various appliances using mobile or web application. Open Remote comprises of three components: controller. This controller manages the scheduling and runtime integration between the devices. A designer, this is second component, that allows to create both configuration for the controller and create a user interface designs and control panels that allow to interact with devices and control them. An IoT based application control the system for smart homes that uses a smart central controller to set up a wireless sensor and actuator network and control modules for appliances. The next application is about intrusion detection. The home intrusion detection system use security cameras and sensors. Usually, we can have a few examples like PIR sensor for detection of the human motion and door sensor whenever you want to find out any person is coming through the door. That we can have few sensors at the door to detect the intrusions and raise alert to the concerned person. Alerts can be in the form of SMS or an email, or you can have call also sent to the user. The advanced system can even send detailed alerts such as an image or a short video clip of the a visitor, which can be sent as a attachment in the email. So a cloud controlled intrusion detection system uses a local aware services where the geolocations of each node of the home automation system is independently detected and stored in the cloud. So in the event of intrusion, the cloud services alert the accurate neighbors who may be using the same automation system or a local police if it is configured. In intrusion detection system based on UPnP technology, the system uses image processing to recognize the intrusion and extract the intrusion objects, that is subject, and generate an universal plug and play based instant messaging for alerting. Next, under home automation, we can have smoke or gas sensor. The smoke detectors are installed in homes and buildings to detect smoke that typically an early sign of fire. Smoke detectors use optical detection, ionization, or air sampling techniques to detect the smoke. Alerts raised by smoke detectors can be in the form of signals to a fire alarm system. So the gas sensors, what it can detect? It can detect the presence of harmful gases in the home, such as carbon monoxide or carbon dioxide or liquid petroleum gas, etc. So a smoke or gas detection raises an alert in human voice. We can incorporate this, describing where the problem is, and it can send an SMS or an email to the user or the local fire safety department and provide the visual feedback on its stats like health, battery low, etc. Next, we can see the second category of the applications related to cities. So under the cities, the various IoT we can have for smart lighting based upon the sunrise, that is sunlight, we can make it on and off time depending upon the how much intensity it is. So, smart roads, it may give speed of the vehicles, traffic which is there in that line, that also you can write in smart. Next, smart parking, where it will signify the vacant spaces or how many parking slots are empty, that you can define as smart. And emergency services. These emergency services can be a fire or gas leakage or water leakage detection in the household applications. Next, surveillances. Apart from that, structural health monitoring. First, we will see the smart parking system. Finding a parking space during rush hours in crowd cities can be time consuming and frustrating. Drivers blindly search for parking space create additional traffic congestion. Smart parking make the search for parking space easier and convenient for the drivers. Smart parkings are powered by IoT system that detect the number of empty parking slot and send the information over the internet to smart application for parking packets. These applications can be accessed by the drivers from the smartphone or tablet or in-car navigation system so that they can find out the parking area easily and they can park their vehicles at appropriate place. In smart parking, the sensors are used for each parking slot to detect whether the slot is empty or already occupied by another car. This information is aggregated by a local controller and then sent over the internet to the database. The design and implementation of the prototype smart parking system based upon wireless sensor network technology with the features like remote parking, monitoring, automated guidance and parking reservation mechanisms. The next applications we can have under cities is smart lighting. The smart lighting system for roads, parks, and buildings can help in saving energy. Smart lighting allow to be dynamically controlled and also be adaptive to the ambient condition. Smart lights connected to the internet can be controlled remotely to configuring light schedules and light intensity. Custom lighting configurations can be set for different situations such as foggy day, festival, or etc. Smart light equipped with sensors can communicate with the other light and exchange information on the sensed ambient condition to adopt the lighting according to the ambience, whatever the conditions which it is having. Based upon that, light intensity or light colors can be varied. The next one we can have is smart roads. The smart roads equipped with the sensor can provide information on driving conditions, travel time estimates, and alerts in case of poor driving conditions, traffic conjunctions, and accidents. Such information can help in making the roads safer and help in reducing the traffic jams. Information sensed from the roads can be communicated via internet to the cloud-based applications and the social media and disseminated to the drivers who subscribe to such applications. In a distributed and autonomous system of sensor network nodes for improving driver safety on public roads is we can have one system can be proposed. The system can provide the drivers and passengers with a consistent view of the road situation a few hundred meters ahead of them for a few dozen miles away so that they can react to the potential dangers early, which is sufficient. That is enough. Next, we can have under cities structural health monitoring. The structural health monitoring system use a network of sensors to monitor the vibrations levels in the structures such as bridges and buildings. The data collected from these sensors is analyzed to assess the health of the structures. By analyzing the data, it is possible to detect the cracks and mechanical breakdowns, locating the damages to the structure and also calculate the remaining life of the structure. So using such system, advanced warning can be given in case of imminent failure of the structure. Since structural health monitoring system use a large number of wireless sensor nodes which are powered by traditional batteries, the researchers are exploring the energy harvesting technologies to harvesting ambient energy such as mechanical vibrations or sunlight and wind. Next, we can have the surveillances. The surveillance of infrastructure, public transport, and events in cities is required to ensure safety and security. City-wide surveillance infrastructure comprising a large number of distributed and internet-connected video surveillance cameras can be created. The video feeds from surveillance camera can be aggregated in cloud-based scalable storage solutions. The cloud-based video analytics applications can be developed to set for patterns or specific events from the video feeds. Next applications we can have the emergency response. IoT system can be used for monitoring the critical infrastructures in cities such as building, gas and power pipelines, public transport and power substations. IoT systems for fire detection, gas and water leakage detection can help in generating alerts and minimizing their effects on the critical infrastructure. IoT systems for critical infrastructure monitoring enable aggregation and sharing the information collected from large number of sensors. Using cloud-based architecture, multimodal information such as sensor data, audio, video feeds can be analyzed in near real time to detect the adverse events. So, response to these alerts generated by such systems can be in the form of alerts sent to the public, rerouting of traffic, or evacuations of the affected area, etc. The system adapts by dynamically adjusting the traffic lights, changing related driving policies, recommending behavior change to the drivers and applying essential security controls. Such system can reduce the latency of the emergency services for vehicles such as mainly ambulances and police cars while minimizing the disruption of regular traffic. The next domain we can see which is related to environment. So under this environment, we can have like weather monitoring, can go for air pollution monitoring, noise pollution, or river flood detection, forest fire detection. So in the weather monitoring system, IoT based weather monitoring system can collect the data from number of sensors attached. So these sensors can be for monitoring temperature, humidity, pressure, etc. and send the data to the cloud-based application and store backends. The data in the cloud can be analyzed and visualized by cloud-based applications in which weather alerts can be sent to the subscribed users. AirFi is one of the weather and air quality monitoring kit which is capable of recording and uploading the information about the temperature, humidity, air pressure, light levels, UV levels, carbon monoxide, nitrogen dioxide, and smoke levels up to the internet. These are the one of the applications where we can have a monitoring multiple physical parameters. Air pollution monitoring. Nowadays, air pollution is a big critical situation we are facing. So the IoT based air pollution monitoring system can monitor emission of the harmful gases like carbon dioxide or carbon monoxide, etc. by factories and automobiles using gaseous and meteorological sensors. The collected data can be analyzed to make informed decisions on pollution control approaches. In a real-time air quality monitoring system comprises of several distributed monitoring stations that communicate via wireless with a backend server using mission-to-mission communication. In an air pollution system, integrates a single microcontroller with several sensors for measuring the air pollution. For sending the messages, we can have a GPSR modem or GSM modem. For position, we can have one GPS modem. The next one is concerned about the noise pollution. Due to growing urban development, noise levels in cities have increased and even have become alarmingly high in some cities. So noise pollution can cause the health hazards for humans due to sleep disruption and stress. Noise pollution monitoring can help in generating noise maps for cities. Urban noise maps can help the policy makers in urban planning and making policies to control the noise levels in the residential areas, schools, and colleges and parks. The IoT based noise pollution monitoring system use a number of noise monitoring stations that are deployed at different places in the city. So from these stations, the data of the noise will be collected on the servers or in the cloud. The collected data is then aggregated to generate the noise maps. In the design of smartphone applications allows the user to continuously measure the noise level and send to a central server where all generated information is aggregated and mapped to a meaningful noise visualization map. Next one is forest fire detection. So forest fire can cause a damage to natural resources, property and human life. There can be a different causes for forest fires, including lightning, human negligence, volcanic eruption, and sparks from the rock falls. Early detection of forest fire can help the minimizing the damage in the forest. The IoT-based forest detection system use a large number of monitoring modes deployed at different locations in the forest. Each monitoring node collects the measurements on ambient conditions for including like temperature, humidity, and light levels, etc. So a system for early detection of fires in the forest provided early warnings to potential forest fire and estimate the scale and intensity of the fire if it is materialized. In a forest fire detection system based on wireless sensor networks uses multi criteria detection which is implemented by the artificial neural networks also. The artificial neural network fuses sense the data corresponding to multiple attributes of the forest fire like the temperature, humidity, infrared and visible light to detect the forest light. The next environment, one of the applications you can have the floods in the rivers. So river floods can cause extensive damage to the natural and human resources and human life. River floods occur due to continuous rainfall which causes the river level to rise and flow rate to increase rapidly. Early warnings of flood can be given by monitoring the water level and flow rate. The IoT based real flood monitoring system use a number of sensors nodes that monitor the water level by using obstacle like ultrasonic sensor and flow rate by using velocity sensors. So the data from a number of such sensors nodes is aggregated in a server or in the cloud. Monitoring application raise alerts when rapid increase in the water level and flow rate is detected. So, in a river flood monitoring system measures a river and weather condition through a wireless sensor nodes equipped with different sensors. In a modes-based sensor network, one of the application research kind of thing for river flood monitoring system includes a water level monitoring module, network video recorder module, and data processing module that provide the flood information in the form of raw data, predicted data, and video feed. So, in this session, we have discussed a few domain specific IoT, mainly for home and city environment. So, under this, what are the various IoT applications we can have, discussed? Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.